Today we're going to be starting in lesson 2 in chapter 3. And we're going to be dealing with slope. Shh. So we got slope for a couple days, and then we'll be using slope from here on out. So today's date is 12/11/15. So first thing I want to do is a definition. We're going to make our own Frere model. I didn't have copies made up. So what we're going to do, remember with the Frere model, you put the word in the center. You create 4 categories. And each one tells you something different. So the first category is my definition. So we're going to give a definition to put here for what slope is. And then we're going to give characteristics about slope. We're going to give you an example of what slope is. And then we're going to give you some non-examples. So we've been studying slope without calling it that for the last couple days. So slope is basically the constant rate of change in a set of data. And our set is going to be ordered pairs, because that's what our tables that we've been studying have been telling us. They've been telling us ordered pairs. And what we noticed is that it is also considered the ratio. And we always put the y on top. And it was the vertical change. So ratio that equals the vertical change, which is the y value, over the horizontal change. Which was the x. So again, it's the ratio of the vertical change y over the horizontal change x. Now, you guys, hi there. So, my question is, you guys should have talked about slope last year and how to figure it out. Not by a table like we've been practicing, but when you saw a graph. Do you guys remember what you did? That you could actually physically count to figure out the slope? Nobody remembers rise over run?
No. I don't think we ever did.
Oh my goodness. Well, that's what we're going to be using to calculate slope, is rise over run. So we'll go in detail on that. Shh, we're not talking. So rise, if you think about it, if you rise, what direction are you moving? Up. And you can actually rise down, okay, and you can go down. If you're running where?
Straight.
Okay, you're running across, so horizontally, right? This is you running. So when we're talking about rise, we're talking about the distance that we had to go up or the distance we had to go down from one place to another. So this is dealing with our delta, means change in our y value, and our run means the difference in our x values. Okay? So again, we're going to go through a lot of practice with this. Now, with each of these motions, there's a sign that's attached. So when we rise, we have 2 options. We could rise up, which is a positive motion. Because if you think about the y-axis and you go up from the origin. If you rise down, that would be a negative motion. Shh. You're sitting there, Dylan, and you're taking notes.
I did.
Okay. You've been talking the whole time. You haven't put anything in that category over there. Look at mine.
Is that a triangle, though?
Look at mine.
Yeah.
Look at mine. Write what I have. You don't have what I have.
I didn't do this.
And then we have run. Oops, run. And we can run right, which is positive. And we kind of had this notion of direction and signs when we were dealing with our ordered pairs and the quadrants that they were in. And then you can also run left, which is a negative. So I'm going to give you an example of how to do this rise over run in this bottom left column. So I'm just going to try to make 4 tick marks on each of my axes, making sure I label positives to the right and up and negatives to the left and down. I've labeled my axes X and Y as I'm supposed to. I'm going to draw a line. I have 2 specific points on my line. And when I'm doing this idea of rise over run, what I'm looking for are 2 points that occur at integers. So I don't want fractions, I don't want decimals, I just want integers. Okay, so for rise over run, to figure out the slope, we start from 1 point, or we could go, doesn't matter. We can start from the bottom point and we can rise up till we get to the level of the second point. So notice that I rose up, which is positive, and I went up 2 places to get from that bottom point's level to the top point's level. It's just a little shy. Okay? That's my rise. To do my run, I go across till I find the second point. So that's my run. And it took me 1, 2, 3, 4 to get to there. Okay, so I had a rise of 2 and I had a run of 4. So to do my slope, let's do dark purple. You guys never did this. This is, wow, okay.
I think we did it. We didn't call it that. Yeah.
Well, there's only one way to call it.
We didn't do it.
To do rise over run, we take the rise number 2 and the run number 4,
I think we just like.
and we simplify it.
I don't think we did that. All of them. We just put it on.
Is that the final answer?
The final answer for slope would be 1/2. Okay? So some non-examples is slope is only for straight lines. So anything with a curve we can't do slope on. So for example, I'm going to give you 2 quick little diagrams. These would be 2 examples that we would not be able to use slope on when there's a curve like that or like this. Okay, so it's only when we have a straight line are we able to use this idea of rise over run. Okay, now what the slope dude just explained to us is that there are 4 different answers you can possibly get for slope. Okay, so let's reiterate. We're going to draw a picture of that. Everybody ready? So let's reiterate what the slope dude told us. He said you would start off and you would go puff, puff, positive, right? Okay. So that portion of the trip, that is a positive slope. And the one point he was making is that when we're looking at a line, we always look from right to left. We don't look from here back. That's why he's always saying you're going to go east, you're always going to look to the right. So you go here and look towards the right. So that's a puff, puff, positive. And then came, what was the next part? Yeah, that was the nice negative. Gravity helps take you down the mountain on that one. So that gave us a negative slope. And then what did he said was happening here? Yeah, he said this is zero fun. So when I have a line, what kind of line do we call that, by the way? Nope.
Oh, cross.
Nope.
Vertical.
Nope. Wow. This is a horizontal line.
Wait, what one are you looking at? Oh, I got it right.
The one that we're talking about. You got it right after 3 wrong answers. I'm not sure how right that was. So a horizontal line is zero fun because it is got a 0 for slope. And then we had like this, whoo! And what did he say about this one? Yeah, this is the math curse word because remember, undefined means it's something you can't do. Oh, let's see. Undefined. Oops, that's terrible. Undefined. So this, and that's it. You don't have a symbol for it. You don't have a number for it. You don't have a sign for it. Shh, guys. It is undefined. This goes with vertical lines. Okay. So vertical lines are undefined. There's no way to come up with a slope. Okay. Let's see what else do we. So I do have this I've seen here. This is called the slope guy. And the slope guy, he's got 2 eyes. Let's see. He looks like positive, negative. So a positive, he's kind of looking like this. Negative, he's kind of looking down like that. So I'm going to color code those. Actually, let me change those colors. So we'll color code it the same as we have here. So positive, his eyebrow is whoop, going up. And then on the negative, his eyebrow is going down. Hi. Okay. So his nose, oh wait a second, let's change his color. His nose is undefined. Get it? The U at the end of his nose line. Jacob, we're taking notes. But it isn't because it's a U, so that's undefined. And his smile, he's got 0 smile. Okay? So that's the slope guy. And that's it for this piece.